Hey friends, it's Rain. I hope you're doing well. I am late again, whoopsies, but the second experiment started last week, which is really exciting. And as I already mentioned last week, we're doing this tetramethylammonium trifluoromethylthiolate, I think the name is, which is a cool little thing because this SCF3 group we have here is lipophilic and thus can easily be, if it's attached to bigger molecules like medicine, it can easily permeate through cell membranes, which makes this super useful. And since this is a salt, so this is negatively charged, an anion, it is relatively easy to make it bond to other molecules. So yeah, that's what we're doing. But we can't just make this thing. We gotta get this SCF3 group from somewhere, which is the first reaction we're gonna doing, because we're taking, let me get my pen ready. We're taking the so-called Langlois reagent, which is an F3C to a sulfur with 2 oxygens and sodium plus minus, I don't really know where the negative charge actually is, whatever. And we're combining that with our triflic anhydride, which has the SCF3 group we need, and we're putting that in chlorobenzene, heating that up to 70 degrees Celsius and letting it stir. And then we get, I'm gonna shorten it, TTST, which has our SCF3 group, the TTST. Oh, I don't want to draw it. It looks like this. That's the TTST. And a side product, which is, oops, that's not a metan, which is solid. Our TTST is liquid, which is cool because we should be able to just distill it over, and this should still be here in the chlorobenzene because that has a boiling point of like 170 degrees. So yeah, that's what we're doing. And on Tuesday we started it. On Tuesday we only built the apparatus, which took us long enough. It was a 3-neck flask with obviously a thermometer, and the paper says to use an overhead stirrer, but we didn't have an overhead stirrer that fit our small 3-neck flask. We only had big ones for like 2-liter flasks, and we didn't want to actually make that much stuff because we didn't have enough chlorobenzene for a 2-liter flask. So instead we used a handlebar stirrer, which is like the little pill-shaped stirrers, but like with 2 handlebars, and can get more stirring power. And then on the other side we had a dropping funnel to have our triflic anhydride in it. And then we prepared on the side a distillation apparatus with a Claisen column, I think it was. Yeah, I think. I'm not entirely sure about naming conventions. Anyway, we had a distillation column on top of it, so distillation is a bit better. So we could then exchange the dropping funnel for the distillation column to have the whole thing in like one big apparatus and don't have to switch it over in between. So yeah, then on Wednesday we started it, which was cool. The triflic anhydride is so we actually had to be a bit careful, and it's kind of cool purple color. It used to be more purple, but now it's not. So we did the reaction, and it turns out the other product we have, this triflic sodium thing, gets like really viscous and really dense. And yeah, it turns out you actually need an overhead stirrer because our handlebar stirrer stopped stirring after a while. So I had to go in there with a magnet and like stir it per hand. But the other group had used dry ice, which was really fun, and I stole some dry ice and put it in water, just let it smoke a bit, which was, it's always good fun to play with dry ice or liquid nitrogen. So yeah, I did that. Yeah, So we stirred it, let it boil a bit, and then we cooled it down, went home, and on the next day, on Thursday, we were supposed to distill it. And we really tried to distill it, but after like pumping it up to 150 C, nothing came over. So we didn't really know what to do. So we went into lunch break, came back, and the assistant was like, yeah, no, let's get into the research group labs. So we lasted a total of 2.5 days in our student lab because the schlenk lines had bad vacuum again and didn't work as they should. So we went into the research group labs and tried to distill there, but we didn't actually distill, we did like a condensation. So we had the flask with our hopefully product and the other product, and we heated it up on one end to like, I don't know, 50 or 60 C, and then connected it with a little tube over to another flask, which is where our product should end up, and we put that flask into a liquid nitrogen bath, so it would be really, really cold. And then we connected that to another schlenk line, which has really powerful vacuum, and we closed the flask with our product in it, and then pulled vacuum on the other flask. So then that very cool flask with vacuum in it would be, we would release the vacuum to the flask with our product in it that is like almost boiling, and so the pressure would drop really, really fast, and our liquid product would just evaporate and then get over into the other flask that is really cold and would instantly solidify in there. That was at least a hope. It worked. We didn't really get a lot. So we, of course, did some spectroscopy, NMR spectroscopy of both our product that like condensated over and the sticky, slimy pudding stuff we still had left. And then on Friday we checked the results of the spectroscopy, and well, it turns out the pudding still had a lot of our product, so we didn't really know what to do. So we just decided to wash it with some toluene, hopefully get some of the product into the toluene, and then distill that some more so we actually have more product that we can work with. So yeah, we did that and built up the distillation apparatus, but since it was Friday we wanted to go home early, so we didn't continue there. We're still on the first step. But yeah, the pudding is unfortunate. So plan for next week is to obviously distill the toluene and hopefully get some more product, and we should have enough time to try the whole thing again with an overhead stirrer this time around and hopefully get better results. So yeah, that's pretty much it. I was basically in lab almost all day, every day, which is a ton of fun. And I got shown around the fluorine labs where they work with HF and CO3, which is cool and dangerous. Those things are really nasty, both of them. Ugh. But cool, and I want to work with them. And yeah, I don't know. Maybe I can get into the research group from a bachelor's. I don't know yet, but it is fun. And I'm having a ton of fun. It's more fun than the first one where we did the tungsten complex. So yeah, that's my review of the second experiment so far. I really like it. Yeah, that's what was pretty much it. Didn't really do much else. Lectures kind of set off to the side for now. I'm gonna go to more lectures next week again. Kind of have to. And yeah, apart from that, I'm basically just wasting my time with video games before the first couple of exams. Kind of scared, but I'll get through it. More lab. Yeah, anyway, I hope you're doing great. I wish you a wonderful week, and I'll see you guys next time. Bye!